Hello students, welcome to video lesson number 2, curved mirrors terminology. So the definitions that I'm going to discuss in this video are basically the ones that you would absolutely need to understand and remember so that you can draw ray diagrams for a curved mirror. Okay, so in this video, I am going to be talking about a concave mirror. So you have your concave mirror. Remember that in a concave mirror, the inside of the cave is the smooth, shiny, reflective surface, and the outside is the non-reflective surface. Let's now understand the anatomy of the curved mirror. We can imagine this concave part, the curved part, as being a part of a bigger sphere like this one over here. Okay, this sphere will have a center. Because it's a sphere, it will have a center. So let's locate that center over here. Label it with the capital C. This is known as the center of curvature of my curved mirror. So if a concave mirror were thought of as being a slice of a sphere, then there would be the center of that sphere labeled as C. It would be known as the center of curvature of our mirror. Next, there will also be an imaginary line passing through the center of curvature and the geometric center of the curved mirror. The geometric center of the curved mirror is known as the vertex, represented by the letter V. So C is the center of curvature, V is the vertex of the mirror, V, which is the geometric center of our mirror. Now there will also be an imaginary line passing through the center of curvature and the vertex. Remember, there is no such line, it's just an imaginary line connecting the center of curvature to the vertex V. This imaginary line is known as the principal axis. PA stands for the principal axis. It's just an imaginary line connecting the center of curvature of the mirror to its vertex. Okay, now in one of the videos from the physics classroom, you probably saw that if you had such a curved mirror and you face it to sunlight, then there is some space closer to the mirror somewhere here where you could place a piece of paper and leave it there for some time, and you will actually see it catch fire. In the video you saw a pencil placed somewhere here which caught on fire. Now that space between the center of curvature and the vertex, that is the space where any ray hitting the concave mirror parallel to the principal axis will hit the mirror and then get reflected through one point. Okay, so if you had parallel rays traveling towards the concave mirror, then these rays will actually meet somewhere between the center of curvature and the vertex. So what I'm going to do is show you some parallel rays coming towards the mirror. This is the direction in which they're traveling, represented by the arrowhead. Okay. Now at this point, remember from the laws of reflection, this ray, when it hits this mirror over here, it will get reflected so that it will follow the law of reflection, which is that if this curved mirror is thought of as being made of tiny plane mirrors, then this ray will hit this plane mirror part of the curved mirror and reflect in a way so that the angle of incidence will be equal to the angle of reflection. Okay, so let me draw the reflected ray. So this ray hits the mirror and reflects in one specific direction so that the angle between the normal over here and the incident beam will be equal to the angle between the normal and the reflected ray. Those two angles have to be equal according to the law of reflection. So you will see that this reflected ray actually met the principal axis at this point. Let's draw another ray which is parallel to the principal axis. It will also hit the curved mirror and reflect in a way that it will follow the law of reflection, and it will reflect in this direction. We can draw a couple more such parallel rays. These will all reflect and they will all meet at one specific point on the principal axis. The point at which all these reflected rays from the parallel beam meet is known as the focal point, represented by F. So F stands for the focal point. So this is actually the point where you would have to place a piece of paper or a pencil or some such object which you wish to get on fire if you were placing it in front of a concave mirror, because that is the point where all the sun rays will actually meet up after being reflected by the concave mirror. Okay, so again, center of curvature, the focal point, vertex, and the principal axis. Now there is an interesting relationship between these two distances, the distance between C and V and the distance between F and V. We will always find that the focal point is halfway through the distance between F and V. So if you take that distance, the middle point of that distance will actually be your focal point. Okay, now this distance between F and V, this distance is actually represented by a little f known as the focal length. Little f stands for focal length. The capital F stands for the focal point, whereas the little f stands for the focal length, which is the distance between the focal point and the vertex. Okay, so once you understand the meaning of the principal axis, center of curvature, focal point, vertex, and focal length, you have the background knowledge in order for you to learn how to draw the ray diagrams for curved mirrors. Also, there are a couple more definitions and some letters that we need to understand, which is what I'm going to quickly describe in the same lesson. What we generally do is represent all objects using an arrowhead. So let's say I had this concave mirror over here placed in front of a tree somewhere here. Okay, I'm not drawing the tree because what we usually do is use an arrowhead to represent any object. It could be a building, it could be a tree, it could be a person, it could be a pencil, any object represented using an arrowhead. So if this arrowhead were to represent a tree, the bottom of the tree would be here and the top of the tree would be here near the arrowhead. Okay, the height of the object is represented by HO. Okay, so let's add on to our list over here. HO is the height of any object. Okay, this object will create its own image. We will learn how to locate that image in another lesson, but the height of its image will be represented by HI. So HO is the height of the object, HI height of the image. Okay, this distance between the object and the vertex is known as the object distance. So because this is this area over here is now really busy, I'm going to represent it in this manner over here so that we clearly understand. The object distance is actually the distance between the vertex and the object represented by DO. DO, object distance. Remember that it's the distance between the vertex and your object. Similarly, DI would then be your image distance, which would be the distance between the image and your vertex. Okay, so make sure you clearly understand all these words, this terminology around the curved surface, because when we will be learning how to draw the ray diagrams, we will absolutely need to know what these letters mean, and we will be using these letters instead of full words so that our ray diagram is not as crowded. Okay, so again, center of curvature, focal point, vertex. The distance between the focal point and the vertex is the focal length, the imaginary line between the vertex and the center of curvature known as the principal axis. Height of the object, HO, height of the image, which I have not shown in this diagram yet, height of the image, HI. Distance between the object and the vertex, DO. Distance between the image and the vertex is represented by DI. We will in the next lesson use these words to draw our first ray diagram.